Hello friends, this is Sagar Gupta. In this video, I will detail out about the process of detonation, which has been a phenomenon of great significance in the field of SI engine, as it affects the engine performance and its running efficiency. Detonation. Detonation is the spontaneous combustion of the end gas in the chamber. It always occurs after normal combustion is initiated by the spark plug. If the combustion process moves too fast and pressure peak occurs too early, the result can be excessive pressure, excessive temperatures, and the unstable pressure pulses known as detonation. Detonation is something that occurs near the peak pressure point in the combustion event after the air-fuel charge has been ignited normally by the spark plugs. Ignition or engine knock occurs simply when fuel pre-ignites before the piston reaches scheduled spark ignition. This means that a powerful explosion is trying to expand the cylinder chamber that is shrinking in size, attempting to reverse the direction of the piston and the engine, causing sudden pressure changes in the cylinder and extreme temperature spikes that can be very damaging on the engine piston, rings, rod, gasket, bearing, and even the cylinder head. Detonation is not necessarily harmful. Many engines operate in light detonation quite regularly. Detonation is not an optimum situation, but it's not necessarily destructive. When detonation damage does occur, it typically manifests itself in the form of fractures of spark plug electrodes and insulator and sometimes piston rings and lands, pitting typically of piston crown, or heat distress, often piston skirt scuffing and piston corner melting. If there is enough heat and pressure in the combustion chamber, detonation can begin to occur before the spark plug even fires, which would normally initiate the combustion. Under these circumstances, known as pre-ignition, the piston may be traveling up toward a wave of compressed exploding gas. These are the worst kinds of detonation condition and can bend conrods and destroy pistons. These are the certain images showing the harmful effect of detonation. Now we will talk about causes of detonation. The main causes are namely ignition timing, lean air fuel ratio, fuel octane, exhaust gas back pressure, intercooler, ambient heat. Now we will talk about them individually in detail. First of all, ignition timing. The spark is advanced, burning gas is compressed by the rising piston, and therefore both temperature and pressure are increased. The increase is the density. Thus, tendency to knock increases with advanced spark timing and decreases with retarded spark timing. By retarding the spark timing, the peak pressures are reached farther down on the power stroke and are thus of lower magnitude. If in a given engine the fuel qualities change and knock take place, retarding the ignition may eliminate the knock, but it will also reduce the ignition power. Now, air-fuel ratio. The most important effect of fuel-air ratio is on the reaction time or ignition delay. When the mixture is nearly 10% richer than stoichiometric ratio, ignition lag of the end gas is minimum and the velocity of flame propagation is maximum. The former effect. Now fuel octane rating. The tendency of an engine to knock is very much affected by the properties of the fuel used. In general, lower the self-ignition temperature of the fuel or greater its pre-flame reactivity, the greater the tendency to knock. Octane number is the measure of resistance to knock. Higher the octane number, lesser is the tendency to knock. Paraffin series have the maximum and aromatic series have the minimum tendency to knock. Now about the pressure. An increase in the inlet pressure increases the overall pressure during the cycle. The high pressure in the end gas decreases the delay period, which increases the tendency of the charge to detonate. However, an increase in the inlet pressure increases the flame velocity, which would reduce the tendency to detonate. But the first effect always predominates, therefore, with increasing pressure, tendency to detonate always increases. How to remove detonation? The most common option used by a supercharger manufacturer and engine tuner looking to obtain maximum performance without detonation is use high octane fuel. That is, high octane fuel burns more controllably and is not as likely to combust before the flame front. Second, retard the ignition timing. Retarding the ignition timing will delay the timing of the spark, which also moves you away from your detonation threshold. Another way to avoid detonation is to cool the incoming air charge to lower the temperature inside the combustion chamber. To lower the temperature of the combusting air and fuel is to run cooler heat range spark plugs. Many supercharger manufacturers will recommend cooler plugs for your supercharged engine. A lean condition of the air-fuel ratio, that is fuel starvation, also contributes to detonation. It is important to make sure that the fuel system is capable of delivering the increased fuel requirement of the supercharged engine. Now we will talk about an harmful effect of abnormal combustion, that is pre-ignition. Pre-ignition is another abnormal combustion event that often confused with detonation, but in fact is completely different. Pre-ignition is the ignition of the air-fuel charge prior to the spark plug firing. Anytime something causes a mixture in the chamber to ignite before the spark plugs fire, it is classified as pre-ignition. Pre-ignition is defined as the ignition of the mixture prior to spark plug firing. This occurs when a point within the combustion chamber becomes so hot that it becomes a source of ignition and causes the fuel to ignite before the spark plug fire. This in turn may contribute to or cause a detonation problem. The ignition source can be overheated spark plug tip, carbon or lead deposit in the combustion chamber, or rarely a burned exhaust valve. Any of these things can act as glow plug to ignite the charge prematurely. Causes of pre-ignition. Sorry. Carbon deposits form a heat barrier and can be contributing factor to pre-ignition. Other causes include an overheated spark plug, too hot a heat range for the application, glowing carbon deposits on a hot exhaust valve, which may mean the valve is running too hot because of poor seating, a weak valve spring, or insufficient valve flash. A sharp edge in the combustion chamber or on top of piston. Sharp edges on valve that will regroup improperly. Mainly, it depends how a combustion chamber is designed. Detonation-induced pre-ignition. Detonation can cause pre-ignition to occur. Detonation causes the very rapid pressure spike near the peak pressure point for a very brief period of time. Pre-ignition causes tremendous pressure that is present for a very long time, possibly the entire compression stroke. It is possible for heavy detonation to induce pre-ignition. If the engine is operating in heavy detonation for a significant period of time, excessive temperatures and pressure spikes which disturb the usual protective boundary layer can cause spark plug electrode and other things in the combustion chamber to overheat to the point where they start to glow red hot. At that point, the glowing item can cause pre-ignition and rapid destruction of the cylinder. This is the diagram showing how pre-ignition occurs in an SI engine. Here we can see that before the spark plug is fired, pre-ignition has taken place at the left corner. Now I will tell you about about PDT, that is pulse detonation technology, that uses the detonation phenomena in the useful manner. Here we can see a pulse detonation combustor and how its cycle function. An engine that runs on PDT is known as PDE, that is pulse detonation engine. A pulse detonation engine is a type of propulsion system that uses detonation waves to combust the fuel and oxidize the mixture. The engine is pulsed because the mixture must be renewed in the combustion chamber between each detonation wave and the next. Theoretically, a PDE can operate from subsonic up to a hypersonic flight speed of roughly Mach 5. An ideal PDE design can have a thermodynamic dynamic efficiency higher than other designs like turbojets and turbofan because the detonation wave rapidly compresses the mixture and adds heat at constant volume. Consequently, moving parts like compressor spools are not necessarily required in the engine, which could significantly reduce overall weight and cost. Pulse detonation engine is a concept currently in active development to create a jet engine that operates on the supersonic detonation of fuel. Because the combustion takes place so rapidly, the charge, that is air-fuel mix, does not have time to expand during this process. So it takes place under almost constant volume. Constant volume combustion is more efficient than open cycle design like gas turbine, which leads to greater fuel efficiency. Thank you very much.